Okay, we're going to take a look at distribution, foiling, and multiplying quantities, and I've lumped them all together here because they're really very much related. They're really at the root the same process, and I'm going to talk about this from this general rule here, where we're going to try to multiply each term in one factor by each individual term in the other factor. Factors are things being multiplied together. Okay, so terms are expressions separated by plus or minus signs. Just to review these examples real quickly, we see in number one we have these two factors, and in this first factor there is one term, and in this second factor there are three terms, which are separated by these plus or minuses. Similarly, in example 2, we see we have two terms multiplying another two terms, okay, and similarly in 3 as well, example 3. I'll talk specifically down here about number 4. It's a little different, but we see in example 5 where we actually have two terms multiplying a quantity of 3 terms. So we're just going to do a matching from the terms in one factor to the terms in the other. Okay? And then in the second step, we're going to combine like terms. Pretty simple. So it's multiply and combine like terms. Kind of like the order of operations. We're going to do multiply, and then combine terms is add, subtract. Key thing here when we multiply is your exponent rules. Is your exponent rules. Okay? And the deal there is we're going to make sure we add exponents for like basis when we multiply. Okay, so let's follow the directions and multiply as indicated. Okay, we see here that I'm going to take this one-term expression, negative 3xy cubed, and multiply it by the quantity of 2x plus 3y squared minus 9. So when I do that, I'm going to take this term and multiply it by this term, and go back to the original term and multiply it by the second term in the other factor, and then I will multiply the original term by the third term in the other factor. Note that I'm including the signs for each term when I do this. It helps me get the sign right in the answer and create the appropriate additions and subtractions. Okay? So let's start with this first one, and then we're going to do negative 3 times 2 for the coefficients. Is negative 6. I'll write the base of x, and I'll see that it's x to the first in both of them, which add up to x squared, and then y cubed. Then moving on to the next multiplication, we're going to get negative 3xy cubed times 3y squared, which is going to give me negative 9x y to the fifth when I add the exponents. And then the negative 3xy cubed times the negative 9 is going to give me positive 27. And then it's just going to be xy cubed because the negative 9 term has no variables in it. We see here that although I do have x's and y's, that they're not like terms because the exponents are in fact not identical. So this is the final answer. It's as far as I can go. Now for the next example, where I have the quantity of x minus b times the quantity of c plus g, I'm going to take the x, which is the first term in the first expression, and multiply it by both terms in the other expression, and then I'm going to also do that for the negative b. So those arches just kind of set up the multiplies I'm going to do. So x times c is xc, and x times g is positive xg, so I'll write add. And then negative b times c, I use that minus as a negative. It's going to give me negative bc. And then I've got negative b times g is going to give me negative bg. Again, I look to see if there are any like terms, and I don't have any. Okay? None of the exponent rules came into play there really when I did the multiply, because in fact none of the bases were similar when I did the multiplications. Okay, very similar on the next example, except I'll give you a little hint in advance. We're going to see some like terms here. Okay, so I'm going to take x and multiply it by the 3x and the 7 in the other factor. And I'm going to take the negative 4 and multiply it by the 3x and the 7 in the other factor. Okay, so x times 3x, you need to realize is not 3x, it's 3x squared. And then I'm going to get x times 7 is 7x. Then I get, again, the negative 4. Okay, times 3 is negative 12x. And the negative 4 times 7 is negative 28. Then I look to combine like terms. As I see, in fact, in the middle here, I have like terms. 7x and negative 12x are alike, but they are not like the 3x squared because the exponent is different. So this will, in fact, give me 3x squared minus 5x minus 28. Okay? Now in example number 4, it reads 2y minus 5, that quantity, all squared, or the quantity 2y minus 5 squared. Okay, well, believe it or not, this is a FOIL problem. Because if you have the sense to realize what it means to square something, you'll realize that it means to multiply it by itself. So you can, in fact, rewrite this as 2y minus, I'm going to write this here for the sake of space, 2y minus 5 times 2y minus 5. Okay? More appropriately, it's the quantity 2y minus 5 times the quantity 2y minus 5. So, continuing for that, I'm going to take the 2y in the left factor, multiply it by both terms of the other, and then I'm going to take the negative 5 in the left factor and multiply it by both terms of the other. 2y times 2y is not 4y, it is 4y squared, because you must add these exponents. Then I'm going to get 2 times negative 5 is negative 10y for 2y times negative 5. And then I'm going to get negative 5 times 2y, again using the sign for the 5. So that's negative 10y. And then I'm going to get negative 5 times negative 5 is positive 25. Okay, and then looking to combine like terms, I see I have like terms in the middle here, which is a common occurrence in FOIL problems. 4y squared minus 20y plus 25. Now, this is the answer. I'm going to go back in this problem and show you something that kids do that is wrong all the time. What I'm about to do here I'll pick a color, I'll pick green, is not correct. This is not right, what I'm about to write. It's wrong. Okay? And you need to say it, because you need to avoid it. A lot of kids see that it's 2y minus 5, and they see that it's that quantity squared, and they say, well, they're going to square the 2y, and they're going to square the negative 5, giving them 4y squared plus 25. Well, when I compare that to the answer I just got, you can see it's wrong because it's missing the middle term. This is wrong. You cannot, in fact, just square both of these terms when squaring the two terms in the quantity. Okay? It's just not legit. You can't do it. Okay? So, we want to totally erase that. Okay? And get rid of it. Now, in purple, I'm going to show you a shortcut here to get this instead of doing this long FOIL problem. There's another video that I want you to watch, okay? And it's about squaring binomials, okay? So it's got a cool little shortcut pattern. When you have a binomial, which is two terms, squared, you could do the following. You could square the left one, which gives you 4y squared. And then you could do the left times the right times 2, which is 2LR. 2 times the left times the right. So we've got the left is 2y, the right is negative 5, so their product is negative 10y. And then if I double it, it's negative 20y. And then I can square the last term, which is 25. So that little process of doing L squared plus 2LR plus R squared, where L and R are the left term and the right term respectively. It's a great little shortcut. I've got another video that goes into that. You could always fall back on doing this FOIL method for this, but you really should be learning this method soon because it really speeds up your process around writing this. Okay, so enough of that. Let's go on to this last example where we see we're going to do a binomial times a trinomial. We have the quantity x minus 4 times the quantity x squared plus 2x minus 8. So I'll take the x and multiply it by the 3 terms in the other quantity. Then I'm going to take the negative 4 and multiply it by the 3 terms of the other quantity. Okay, so I have x times x squared. Again, the exponent rule is to add them. Then I've got x times 2x. Again, I'll be adding exponents. We'll do 1 times 2 is 2. Write the base. X times x is x squared. Then I'm going to get x times negative 8, which is negative 8x. Then I'm going to get negative 4 times x squared, which is negative 4x squared. I'm going to get negative 4 times 2. Again, you got to make sure you're using the negative sign with it when you're doing the multiply, which is going to give me negative 8x. And then finally, negative 4 times negative 8 is positive 32. Now, when I go to collect like terms here, I notice that I have an x cubed, and none of the other terms are x cubed. And then scanning, I have an x squared, which is 2x squared, and then another x squared where there's negative 4x squared. I'll combine those. And then I've also got negative 8x, another negative 8x. They're both x's. I can combine them. So just getting to work on that, I will pull down the x cubed. Then I will get negative 2x squared. When I do 2x squared minus 4x squared, the exponent stays the same here. And negative 8x minus 8x is negative 16x. And pull down the 32. And that is your final answer. So again, when you are doing these multiplications, you're taking all the terms of the first quantity and multiplying them individually by all the terms of the second quantity. Quantity or factor here. Factors are things being multiplied. Okay. We also see with a lot of these parentheses we're involving quantities. Okay, so feel free to watch this and give it another shot at your leisure. Okay, I encourage you to, in this number 4, try and check out this squaring binomials video that I have. It really focuses on the shortcut there of squaring binomials and shows a few more examples.